This session is what the EF, common ORM problems and how to fix them, which you should know if you're here. I wanted to start off by saying thank you to a few people, in particular, the organizers of the New Stars of Data Conference and all the folks involved, the moderators, the Magnus, my mentor. I'm just really grateful for the opportunity to be able to give this talk and all the work that goes into, putting this thing together. So thanks so much to all of you. And I'd also like to say thanks to the folks that encouraged me to blog and speak. I've been blogging for about 3 years now, and the folks that encouraged me to do that know who they are. And this will be my first time speaking, also at the behest of and frequent encouragement of those same awesome folks. I'd also like to give a special thanks to Forrest, who is watching right now. And he is the one who came up with the name. He's a pun extraordinaire. And I had the session idea, but he had the what the EF name, which I thought was really funny. So I submitted it that way. Beyond the thank you, it's time for boring slides. I think that's part of the process here in giving these presentations. So the slides will be appropriately boring, like any PowerPoint presentation. But hopefully the content is interesting and you guys all enjoy it. You folks all enjoy it. Just a little bit of introduction. My name's Josh Darnell. I'm a .NET developer and a SQL Server enthusiast. I've been writing .NET software for about 10 years now. And I've been using SQL Server that whole time, but recently in the last 3 or 4 years have really gotten deeper in my interest in SQL Server and kind of understanding how to interact with it in a good way from our .NET applications. I blog at joshthecoder.com. You can check that out. I'm also an active contributor at Database Administrator Stack Exchange and at topanswers.xyz. Both of those are Q&A sites about different things, mostly database related. So that's who I am. And then what are we going to talk about today? For those that don't know, if you don't know what an ORM is, I'm surprised you joined this session. But an ORM is something that takes object data, like from a .NET application or a Java application, and converts it into T-SQL queries so that developers don't have to write the actual SQL statements. This simplifies things for developers because not all of us know a lot about writing queries in the database itself. And it's a big domain and there's a whole ecosystem and profession around writing queries. So definitely takes a lot. But like any tool, ORMs, the garbage in, garbage out rule kind of applies there. And essentially that's, if we're not using the ORM correctly, we're not going to get the best results out of it. So I've seen a lot of ORM usage over the years, and I think there are a handful of simple rules and guidelines that we can follow to avoid some of the biggest query generation pitfalls. And then there are some more complex things that require a little bit more knowledge, a little bit more forethought, but they also give you a lot of bang for your buck. So I'm going to talk about those things today. A couple notes about the setup. My demos are using the Stack Overflow database, the public Stack Overflow data dump that is produced by Stack Exchange and I don't own this data, of course. They provide it for free, and the license requires that if you use it, you need to provide attribution. So that there's the website, and yeah, it's, like I said, the sample data here for these demos is the Stack Exchange public data dump. In my database, I have batch mode on row store disabled. That's mainly because batch mode on row store is like a cheat code for query performance. I mean, it just makes certain queries that consume a lot of data run much faster. Since most folks aren't on 2019, I disabled that just to make the demos a little more realistic to what you might experience. I know plenty of people are still on like SQL 2005 and 2008, so probably be a while before we get to a lot of 2019 adoption. I've also got forced parameterization enabled. That's pretty common for ORM databases, or databases where the application uses an ORM, because ORMs tend to produce a lot of ad hoc SQL that can benefit from forced parameterization. I'm using Entity Framework Core in these demos. That's kind of the new latest and greatest Entity Framework. All of these items all these issues do apply to EF6, and the code is similar to resolve these problems, but it's not exactly the same. And these problems also apply to other ORMs. I worked for 5 or 6 years on an application that used in Hibernate, which is another popular ORM. Popular in terms of adoption, not popular in terms of like winning a popularity contest. I don't think a whole lot of people like it in that way. I'm also going to be using extended events to view the queries being executed. You can also see that in Entity Framework logging. So with all that out of the way, let's start with Sprint 1. I'm going to use some Agile terminology and make fun of Agile some, because it's it's fun to do. And I think many people can relate to it. So Sprint 1 here in my presentation is the N+1 Query Problem. And just for those that don't know anything about Agile, a sprint is this construct in Agile where the team decides on a set of work to do during a 2-week period, and then it kind of, the work remaining burns down. This is a burn down chart. It burns down over the course of the sprint. Usually it actually looks like this. Might go down a little, might go up, and then you end up with more work than you started with. At least that's been my experience on sprint teams, Agile teams.
Just to add here, mine as well.
Yeah. The N+1 query problem is this situation where you're running a query from an ORM that returns 100 rows, but what it ends up doing is executing 101 queries. So if you're running a query that returns n rows, you end up running N+1 queries. And so we're going to dig into how that happens and how you can fix it. But first, I really want to tell a story about how we can, like, developers and DBAs can work together to resolve these problems. And I think part of the breakdown is that we don't have a common language to talk about these things. And so I'm going to tell a story and use an illustration with these 3 folks. This is the developer, the project manager, and the DBA. The project manager is going to be a punching bag in the story. I apologize in advance to any project managers who have attended this session. I don't take it personally. So yeah, let's jump into this N+1 query problem. So here we've got our developer, and he's arrived at work. You can see he's at the bottom of the stairs. He actually works down in this little basement by himself, which he's fine with because we know how developers are. And he just got to the office, and already the project manager has come to his desk, to tell him hi, to tell him They've got a new feature request. It needs to be done this sprint just as soon as possible. And what they want is a button you can click that will show 100 comments from the from the Q&A website and who left those comments. So being a good developer, he's got some questions about this. You know, did anybody really ask for this? This doesn't make any sense. Like, shouldn't they be in a particular order? And the project manager dives into this long explanation about user stories and A/B testing. Developer's kind of phasing in and out of paying attention. He's thinking about his coffee. The project manager continues to go on their thing. The developer's thinking about his Dungeons and Dragons game he's playing later that day. And he kind of zones back in as the project manager's leaving. So our developer has to get to work on this feature. It's very important to the business. So let's take a look at what he did. So this is .NET code that's running on a web server. And we've called this top 100 v1. And the way Entity Framework works here is that there's a context that you use to access the database. And then there are list properties on there that let you query the different tables in the database. So what we've done is use take, which in T-SQL translates to top. So we're going to take 100, toList runs the query, and then we're going to split out just the user display name and the text of the comment and send that down. So hopefully this code is pretty straightforward. I did want to ask, and I don't know how folks could answer it, but if you want to post in the comments or something, you know, has anybody in here actually written Entity Framework code or worked with Entity Framework directly versus being a DBA that's just being abused by Entity Framework queries? I'd be interested to know that. But I'll keep kind of chugging along here. So
I can tell from the chat that there are people who did that. And I can confirm from my past, I started out as a web application developer. I did this also with my past. So, yep.
Awesome. Great. Yeah, I think that's I mean, in my experience talking with DBAs and data developers, it seems like a lot of folks started out doing application development. So hopefully all this stuff is pretty relevant to you all. And it's not too opaque in terms of the C# code. But developer's done with the code. He ships it. Now we've got a button on our website. It says top 100 comments v1. So I'm going to click on that. And it didn't take too long to show my output. So he feels good about it. He's done. This is good. Unfortunately, while he's doing this, the DBA has spun up an extended event session. Just for a little bit of aside here, the extended event session I have set up is capturing the RPC completed event and the SQL statement completed event. Most Entity Framework queries will fire this event because they're parameterized, and so they're using SP_execute SQL. If they don't have any parameters, this won't fire because it just sends the query directly without parameters, without the dynamic SQL part of it. So I'm going to fire up. We've got the extended event session running, and I've got live data showing here. And so I'm going to go back in, click this button, and what the DBA sees as he's looking here is just the server is just getting hammered with all these queries against the user table. And over here, you can see each query has a different ID. So it's just basically doing singleton lookups against the users table on a bunch of different users. And if we go all the way to kind of the inciting incident here, there's a query against the comments table, which is what the developer intended to write here. and that's the select top 100 comments. So hopefully everybody can see that okay. I'm in the wrong database context. So yeah, what's going on? Oh, now there's all these SSMS queries in here. But so what's going on with this? So the DBA goes in, so it's time to talk to that developer. And the DBA is angry. He says, look, your application's got this chatty API. It's sending too many queries to the database. Like, haven't you heard of a join? You can just join to the users table to get those instead of querying row by row every user you need. So look, I need you to go back and fix this. We can't go to production like this. Developer's mind is kind of blown. He doesn't know what's going on because he just wrote one query. But if we look back at this code, what's really happening is because we just said we wanted comments, it really just runs that query to get the comments rows. And Entity Framework has this feature that's on by default called lazy loading. And what that's going to do is every comment has a user attached to it. It's the person that left the comment. But it's not going to pull that user into the data set. It's not going to query that user from the database until you try to access the data on that user row. So when I pull these values out for each iteration in the loop here, as it goes over the comment results, it's going to run a query against the database to get that user just so we can get their display name. So how do we deal with it? How do we fix it? We know the problem now. So the developer does some Googling. He goes in and he finds out that you can use the include function to tell Entity Framework, hey, I want the users up front. As soon as you run this query, I want to get all the user data. Instead of doing this lazy loading thing, this is eagerly loading. And it translates to a join in T-SQL. And so that's the only change we've made here is to say include users when you get these comments. So I'm going to go. The developer's made his changes. He's got V2 of the comment feature. And I'm going to clear out the data we've got so far and then run this. The program output didn't change, so we feel good about that. And now what the DBA sees is that we've only got one query that ran here. So that's mission accomplished for this problem. We can see if I pull this out onto a slightly bigger view of things, and I'm going to get rid of the dynamic SQL as well, just so it's a little easier to read with the syntax highlighting. But we're selecting the fields we want, and we're getting the top 100 comments in a subquery and then joining to the users table. I think it's a little odd, the subquery approach, but it works. DBA is pretty happy that there aren't a bunch of queries running at once. You might notice that before there were 66 queries running, not 100. So it wasn't exactly N+1. And that is because Entity Framework does do some caching. So if the same user row is going to get selected again, it's not going to run that query multiple times. It's going to cache those. So in any case, problem solved. So we've figured out this N+1 query problem. In general, lazy loading is our friend. We do want to do that lazy loading. If you think about a user object that has a list of answers they've posted on it, so, a user may have posted hundreds and hundreds of answers. And so if we're loading that user, we probably don't want to load hundreds and hundreds of answers every time we load that user if we're not going to use it. So in that sense, the lazy loading is helpful. But if you know you're going to use that data, like in this example, we should always use an include to get that join behavior and avoid this rapid fire singleton lookup approach. So that's sprint 1. Any questions about sprint 1 while I take a sip of water?
No questions so far. All good. I think we are all, and we have developers and DBAs in the attendee list. So you're catching all of us.
Awesome. That's great. That's the people we're trying to bring together here. We're all a big family in this together, battling against our project managers. All right, so on to sprint 2. Select star is evil is what I've called that. So you've probably heard this a lot if you're a DBA, not to use select star. The default behavior in Entity Framework is to get all the columns whenever you run a query, which is really convenient for developers. You know, that way you have access to everything, whether you need it or not, just in case. But if you've done query tuning, you know that selecting all the columns in every query makes indexing very difficult. Because if you create a non-clustered index, you can't put all those columns in there most of the time. So that's going to result in key lookups. And after a certain number of key lookups, you're not going to, the optimizer is going to choose not to use that index. If you want to learn more about that, there's a lot of blog posts out there. Kimberly Tripp has a kind of seminal series of posts that refer to that as the tipping point. So that's something to check out. It's also just generally wasteful on resources. You know, you're sending all of this over the wire when you don't really need to. So the last time we saw our developer, things were going pretty well. He got this thing down from 60 something queries to just 1 query. The feature's working well. The DBA is going to come along, and he's actually in a much better mood now. Feels like there's some good positive collaboration, but he wants to talk about that select star issue. Because in this screenshot, this is that query where we end up using just 2 columns, and we're selecting all these columns just to use those 2. So the DBA explains exactly what I just mentioned and leaves the developer to take a stab at that. So let's take a look at the code for version 3 of our top 100 comment feature. What the developer finds out through some Googling, probably copying and pasting code off of Stack Overflow, is that if you can use this select function to define the select list for your query. So we're going to use the select function instead of in our previous iteration of this code, we did that after the query already ran. We can see we ran the query with this toList call, and then we're using select on the result set after it's already been retrieved. So here we're telling Entity Framework before we run this query, all the columns we want are defined in this function call. So that's user display name and text. So now we've got our include for the join, we've got our take for the top, and we've got our select defining our select list. So let's publish that button onto the web page, and we will again clear out some of this stuff that's been picked up by the extended event session. I'm going to click run. We still got the same results, so we're doing well there. And now the query that got executed is tiny by comparison to what we saw before. This was the previous query with our very long select list. Compared to this little gem that's just selecting display name and text For the purposes of the join, it's also getting the user ID out of the comments table, but it only returns display name and text to the client application, our web app in this case. So that looks like a win. The DBA sees that flowing through his extended event session, and he's pretty happy. So at this point, developers worked hard on this sprint, these 2 sprints. So he's heading home. He's heading out of here. Yeah, and so just to summarize on sprint 2, select star is evil. I think when you're writing entity framework, there are exceptions to any rule, but in general, I would say you should always be running that select function when you run entity framework queries. That should just be a baseline choice you make. So any questions so far about that, the select operator, or the kind of defining the select list for our queries?
All good so far.
Excellent. Sprint 3 is about getting too much data. It's not always obvious when a query is running in Entity Framework. So different things can trigger the query to run. You define a query specification in Entity Framework, and then it runs at a later time potentially. Most of the time I'm calling toList to force it to run, but other things can cause it to run, like the count function, for instance, will cause your query to run, or the single function, which would just be trying to get 1 row of data. So things that trigger the query execution, it's not always obvious unless you know about these things, when or why that's happening. And this can get us into trouble. And you can see here, this is the profiler in Visual Studio showing memory going up. You're going to see that in just a minute here. And as a side note, after Sprint 2, the project manager did not like how long that took, did not like that it took 2 sprints and 3 iterations to get this code out the door. So he got fired. We're done with this developer whose name was Josh. No relation, by the way. It's not me. Don't worry, I didn't get fired yet. But here we've got Alice. So Alice has been hired to replace Josh. So let's say hello to Alice coming in the door. She's down here in the basement too, because that's where they send the developers. Hot on her heels is the project manager. Now the project manager's staring at his phone. He's got emails coming in. He's got several meetings he needs to attend right now. He says, "Hey, Josh." And Alice is like, "I'm not Josh, right?" And he's like, "Look, I don't have time for your messing around, Josh. We've got problems to solve." So Alice is like, "Whatever. I don't have time to deal with his bad attitude either." So we got a new feature request in, and that's that we want to see the top users on the site, people with more than 10,000 reputation points, and we want to see them ranked top to bottom and to be able to page through that list. Alice has some questions because the project manager has defined some rules. There's only 20 users per page and reputation greater than 10,000. But, she kind of wants to know, why 10,000, why 20 users per page? And look, the project manager is quadruple booked. He's got to get out of here. He's got to get to his other meetings that he's assigned to. So Alice is stuck implementing this as requested. So let's see what she did. We're going to go into our users controller, which has by reputation V1. We know that we need 20 rows per page. So I'm just going to kind of talk through this code, and you might look at this code and say, nobody would do it this way, but trust me, people do it this way. So this query is saying, give me all the users where the reputation is greater than 10,000, ordered by reputation descending, so from highest to lowest, and then run the query. And then we're going to take that page and calculate the offset that we want in that list of users by multiplying 20 by the page. And then we're going to loop through that list and just starting at that offset and get the 20 that we need. And build out our display name, our reputation, and send that back to the client. So hopefully all that makes sense. I muted my mic so I could clear my throat, and then I couldn't get back to the mute button. So she's published this new function to the website, and it looks like it works. We've got John Skeet at the top, of course. If anybody's used Stack Overflow, you knew that was coming. And if we click the button, we get more and more pages of users. But as I mentioned, there's this problem. We can see the RAM usage of our process is just going up and up every time we do this. So what's going on here? Well, the DBA is looking at this code as it's running, and he sees what's going on. You know, we're getting all the users every time that have more than 10,000 reputation points. And it's probably hard to see on the presentation, but there's a row count on this of 14,611. So we're getting all 14,000 users every time. And those get, you know, pulled into the memory in SQL Server, they get sent over the wire, and they get pulled into memory in the .NET app for all but 20 of them to be discarded before they're sent back to the client. So this is a very wasteful operation overall. So here comes the DBA. He's still got a pretty positive outlook on life. He welcomes Alice to the team. He talks to her a little bit about paging. He's like, look, you know, in T-SQL, you can use these offset and fetch features to limit your result set so that you're not having to send back all those thousands of users. You can just get the 20 you want. So give that a shot. Let me know how it goes. So Alice is back to the drawing board here with V2 of the by reputation function. We've still got our 20 rows per page, but what she found out is that you can use these functions called skip and take in Entity Framework to translate into offset and fetch in T-SQL. And so that's what this does. We're getting the users with greater than 10,000 reputation points ordered by reputation descending. We're doing our offset and fetch in the database. And Alice also learned the lesson that we should provide a select list and we're not getting all those columns. So if we go back to our web page, we've got V2 of our API here. And we're back to page 1 with John Skeet. We're paging through. It looks like this is working just as well as it was before. But now we can see memory is stable. No matter how many times I run that query, we're not blowing this thing up. And if I go over to the extended event session, we can see that this did in fact translate into an offset and fetch query where we're ordering by reputation, just like the kind of normal paging query you're used to seeing in the database. So this was a good day. I mean, just one extra iteration on this code and we got it to where the developer's happy with it. The DBA is happy with it. There's some good collaboration. So Alice is going to head out now for the day. So the takeaway there with Sprint 3 is developers aren't always aware of all the query features available to them. I know 10 years ago when I started writing .NET software, I didn't know about offset and fetch in SQL Server. So I would have done things exactly that way, the way that first implementation went. So the big takeaway is we should always do as much filtering as practical in the database to avoid wasting memory, network traffic, you know, all kinds of stuff like that. Any questions about all that?
Still all good. We are all on board.
Wonderful. we've got it all figured out. Sprint 4. We're going to talk about this word. When I read this word, my first response is to say, what? And then seriously, what? But SARGability, the SARG part stands for search argument. I'm not going to go into like a really deep dive into the details of how this works. If you do want to read more about it, I would suggest just Googling SARGability, Eric Darling. He's written a ton about this topic, and there's a lot of great stuff out there. But just to talk about what's relevant to this presentation, let's think about the phone book example of indexes. And I know what you're saying, a phone book, what year is it? But if I told you, phone book is a list of names ordered by last name. And so if I told you to look up all the Darnells in the phone book, that would be pretty easy for you. You could kind of flip right to that page or that set of pages and read them off. But if I told you to find all the Joshes in the phone book, that would be a lot harder. You'd have to flip through every page because there's no way to jump to the Joshes. So let's see how our developers are running into SARGability problems. Oh, and after the previous sprint, in sprint 3, the code went well. They had a big release party. At the release party, the project manager decided that he didn't like Alice's hat, so she got fired. So now we've got Jane. Jane is coming in to replace Alice and Josh. And so she's heading to her desk down in the developer basement dungeon, and the project manager is hot on her heels. He still thinks that it's Josh sitting behind the desk because he's pretty focused on his own problems. Jane tries to correct him, but he just wants her to quit messing around. They've got a new feature coming in for birthdays. So they want to send some swag to everybody who has a June birthday. And so the first part of that is we need to get a count of all the users who have June birthdays, and so that we can figure out how much inventory to order. Alice thinks this is a weird idea, but she knows better at this point than to push back on the project manager's ideas. So she just kind of rolls her eyes and lets him head on to his sprint retrospective. So let's take a look at Jane's implementation of the June birthday feature. So we've got our users context here, our users list on the context, and we're going to say where creation date.month is equal to 6. You may notice I'm using creation date here. I'm just taking some creative liberties with this whole thing because the Stack Overflow database doesn't have people's birthdays. So we're just going to pretend that creation date is birth date. Just suspend your disbelief, let's all have a nice time doing that. So this is the implementation. Let's see how it runs. Looks pretty good. We've got 791,000 people we need to send swag to. But what's wrong with this approach? If we take a look at our extended event session, we see we've got the query select star, and it translated that creation date.month into this date part function that's running on the creation date column. And this has exactly the problem we were just talking about. And that's it. There's no way for this thing to seek into the creation date. Or rather the 6 there. And we can see that in the execution plan. We've got this parallel query. It's reading all 9.7 million rows from the clustered index. It's running at, I think it's running at DOP 6 or 8. DOP6. So we've got 6 threads doing that scan and partial aggregates on each thread, and then it comes together and does the global aggregate, kind of finishing off the count. So database administrators coming in, welcomes Jane to the team and wants to talk about SARGability and how you can get that query to run a little more efficiently. And so what he gives her some ideas and heads back to his office. And so we're going to take a look at what Alice has been working on. And so what I'm going to do is expand this. And this was kind of a trick question thing, because in this case, there's really not much you can do with the query. I mean, we need to get it that month, and there's just not a good way to do it without running a function on the creation date. But because of the collaboration between the knowledge that the database administrator had and the tools that the developer has at their disposal, she found out that she can actually get a computed column created on this table that pre-calculates the birth month. And then we can create an index on that pre-calculated value. And so in this case, the index is done. We don't really have to run that query again, but she didn't even have to change any of her code in this case. So if we look at the results of that query now, we've got this serial. So it's not parallel anymore. It's just using the one execution thread. It doesn't read 9.7 million rows. It only reads the 791,000 rows that are needed for the results, aggregates them, sends them back. This uses far less resources. It's a pretty efficient operation overall. Now, that's not the only way to solve that problem, but it just goes to show that we need this collaboration so that we can share knowledge across teams that everybody might not have. And because Jane finished that so quickly, she was actually able to pull another feature from the backlog that also, just secretly, it also relates to SARGability. So we're going to stay here. So the search users function we have was in the backlog. So she goes ahead and pulls it in. And we'll just kind of close out of this. So we've got our user search. And the way this works is the app submits a display name. And she doesn't want to miss anything. So she's converting them both to uppercase so that we make sure they match and we don't have any problems there. And then selecting the display name. So this works. In this case, our app is submitting Josh D, and there are like 17 or so Josh Ds in the database. And now Jane is being proactive, and she looks at the execution plan for this thing, or the generated query here, and says, "Oh, you know what? I'm running a function on the search column. So this is that SARGability problem. We don't want to have that." In addition, she actually pre-created an index on the display name column. So she was hoping that index would get used, but it's not. It does use the object, but it scans the whole thing, all 9.7 million rows. So she didn't get the benefits of that seek. And so what she ends up doing is she calls up the DBA and talks to them about this problem. And what she finds out is that the database is in a case insensitive collation. So converting this to upper is unnecessary. We can just run the query doing an equality comparison on the user submitted display name, and it'll find all the matches we need. So if we run this, let me just clear this out and run that again. So if we run this search users v2, we get the query without upper. It's just a equality comparison, u.displayname equals the parameter at display name. We've got a serial index seek. It only reads those 17 rows, and it's done. So Jane feels pretty good about this. So she's finished that up. She got a promotion because she did 2 features in 1 sprint, where Josh did 1 feature in 2 sprints. So she's on everybody's good side here. So the takeaway with that SARGability bit is we need to try to avoid doing things that make seeking impossible. A lot of times that's running a function on the column we're searching on, or doing a contained search on text, or something along those lines. And so we either need to fix the query, or we need to get creative. You know, maybe we can push back on the requirements and say, hey, instead of doing a contained search, can we just do a starts with search and do that as our V1 of this product? Or in this case, maybe we can have a computed column, you know, like we did with the birth date thing, to support that query. So yeah, that's it about SARGability here. Any comments, questions about that?
Still all good.
Awesome. And thanks for the heads up, Gabby, about the 15 minutes. Okay. So that's the end of our sprints. And it's certainly not because I got tired of animating little scenes. That couldn't be it. But I do have some honorable mentions. So I think those 4 things are really the most common big impact items I see. If we can resolve those, we can resolve a lot of the EF problems that I see on a day-to-day basis. Honorable mentions here that I think are interesting and can be helpful. Kitchen sink queries are kind of the classic search screen where maybe you're searching comments, and you know, you've got like a text search field, and like you can filter on the score, and like a start and from for the created date and all this stuff. And it's kind of sending all these different parameters to this one query. And the biggest problem with it is that all the parameters are optional. So what you end up with is a query that looks like this. And we're querying the comments table, and we're saying we've got our nullable from and to dates, and we say so the creation date is greater than the from parameter, or the from parameter is null. So if it's null, we don't want to filter at all. And if it's not null, we want to use that. And this is just a nightmare for the optimizer, because it has to plan for all of these things to be present, even though, you know, usually all of them won't be. And so what you end up with is this catch-all query plan that's not optimized for what the user is doing in each search instance. So one of the really cool things that Entity Framework Core does is it detects this situation, and it gets rid of the parameters that are null and are not being used. So in my case, I've got this search comments button here, and we can see that returns some program output. And if I look at the query that was generated, I only passed one parameter. I passed the score parameter in the code, which you couldn't see the client code, but I just wanted to see comments where the score was higher than 300. And so what you'll see is that it actually ignored all of those other clauses in the where clause, all of those other portions of the where clause. So Entity Framework Core will actually do, so the normal T-SQL solution to this kitchen sink thing is dynamic SQL. And so you only append those parts of the where clause that you need. And so this is a great advancement in EF Core because it detects that and it removes those clauses automatically. It does this kind of dynamic SQL approach for you. In earlier versions of Entity Framework, like EF6, for instance, you had to do that dynamic SQL thing manually. And it looks like this. So I'm going to comment this out and uncomment this just so you can see it a little better. But you basically define your query, and then if the from parameter was passed in, we'll add this to the where clause. And if the to parameter was passed in, we'll add that to the where clause. And so we build up this dynamic query object. And then at the end, we run it after we've assigned only the filters that are required for our search arguments. So this is the way to solve that in Entity Framework 6 and in Hibernate. I initially wrote this as one of the main parts of the demo. And then I was shocked to find that Entity Framework Core was doing that. I guess it's like, yeah, that dynamic SQL thing where it detects these unused clauses and removes, it doesn't generate T-SQL for them at all. So that was cool to find out. But if you are dealing with legacy EF, which most people probably are, you can use this approach. Let's see. And feel free to stop me if there are any questions about any of these things, but I'll just kind of keep going through them. You can use query hints in Entity Framework. It's not super easy, but query hints are kind of a nice tool in the tool belt of a DBA. And it's tough when an application is generating a SQL, because usually the approach to putting a query hint on a query you'd have to use a plan guide. It's hard to make sure that things are matching. And potentially if there's a lot of plans that need that, then you're in bigger trouble. But what you can do in Entity Framework Core is set up this thing, and I'm just going to show the code. You can set up this thing called an interceptor. And I've called this N+1 command interceptor. And what you can do is intercept every query that's generated by Entity Framework and actually manipulate the text of the query before it's executed. So this is hugely helpful. It's also hugely unsafe for most use cases, but for appending something to the end of a query like this. So what I've done is I've just detected the query I want the best I can. So if the command starts with select top parameter u.displayName, u.reputation, then I'm going to append option N+1 to the query. Entity Framework Core also has a feature where you can tag queries. And so if you do that at where you define the query, you can tag it with some unique text. And then you can reference that here. It makes it even easier to kind of target the queries you want with hints. Because sometimes, you need to limit something to N+1 or disable batch mode, or, whatever it is, use a fast one hint, there's lots of different reasons you might use a query hint to improve things. And so that is possible. It's not the most straightforward thing, but it is possible. So I think that's something that is kind of a disconnect between developers and DBAs a lot of the time, is that they don't know about that. This last one, I'm not going to show any code related to it, but don't mix literals and variables in your C# code that's generating the queries, because that makes things difficult for the forced parameterization feature I mentioned earlier. The query engine can't parameterize a query with literals in it if there is a mix of literals and parameters. So it just kind of hamstrings that forced parameterization feature, which is tough because that can be really helpful for these ORM workloads. So I'm just going to kind of summarize the big picture things here. These are questions I always ask when I'm writing an entity framework query. Do I need includes? So I look at what's being used and I say, is this going to result in lazy loading, a problematic lazy loading that, runs a bunch of queries rapid fire against the database? So do I need includes, and if I do, then I'm going to add those and use joins instead of that lazy loading. Do I have a select? Like I mentioned, I pretty much, you almost always want that select function to be run as part of your query. So define this, the select list in the T-SQL using that select function. Am I filtering early? And that's the paging example I made, but there's other times when it's easy to pull too much into memory, too much into the application when you really just need a few rows. So I try to make sure, as I'm writing this query, like, am I pushing as much of the filtering as I can into the database? And so those are the easier ones. I think the tougher ones are, is this query sargable? So, look out for those function names being run on filter columns. And does this need an index? And this kind of blurs the line when it comes to using ORMs because, we're kind of abstracting away the use of the database. But it's important when I write a query, it's got a where clause usually, and I should be thinking, does this need an index? Is this table going to be large enough that I need to seek into this? So it's something I try to think about anytime I'm writing a query, is just run through these handful of questions. And it really results in a lot more stable, reliable, predictable code being generated by the ORM. So in summary, ORMs aren't that bad. ORMs are bad some of the time. And as my friend Eric Darling likes to say, databases were a mistake. And again, thanks everybody for your time today. We've got a couple, I think 2 or 3 minutes left. If you have any questions, while those are kind of coming in, if they are. I did all those animations for the little project manager and the little kind of cartoon to tell the story. I used this tutorial, this Marty Himmel is really good teacher. I purchased the art assets from these websites. So in case you're interested in doing something like that yourself. And that's it.
Okay, thanks so much, Josh. Perfect in time. We don't have any questions at the moment. I'll wait for another minute. But
See the
perfectly
applause
fine.
from
And
Magnus.
thanks for taking us on that journey. And yeah, I appreciate that amazing 3D picture as well. So that was really cool. And thanks for that amazing flow. I really think following on that journey of that developer's life is actually really, really helpful. Oh, there is a question actually. Are there scenarios from Forrest? Are there scenarios when you recommend moving a query from EF to a procedure?
Yes. I don't end up in situations where I need to do this often, but if a lot of times like a query tuning approach that's really effective is using a temp table to kind of filter down the results, especially if it's a really complex query. So if you need that temp table approach, then you're going to need to use a procedure because there's just not a way to do it with Entity Framework. You might be able to kind of create your own little temporary collection and then filter with that in EF, but usually if you've got something complicated where you need to break it down into multiple steps, then a procedure is a better way to go.
Yeah!